Okay, so continuing where we left off, at 2 years, we were at $44,944 in our table. So plotting these points, we're going to go ahead and plot 1 year. So at 1 year, we're a little over 42,000. 2 years. And then 3 years, looking at my table, it looks like at 3 years we are $47,640 approximately. And then up to 4 years, so where I'm getting these numbers, you could just plug the number in for t. So you could plug 3 in for t, and then you would get out this number. Plug 4 in for t, and then you can get out this number. Or you can plug the function in and then go to the table, and it'll have all the numbers listed for you. 3, 7, 3 years, 47, 4 years, 50. So it's really supposed to have a little bit of a curve to it, not linear like it looks. Starting at 40,000. So you just use your table. When you're doing the 60,000 one, looking at your table, you're going to have to approximate the value. So 60,000. Okay, looks like it's going to be between 6 and 7 years before you make $60,000. So it'll actually be your 7th year that you'll hit 60,000. Okay, let's move on. So just a quick review, growth and decay. Here you have your initial amount, the A value. Now your base, it's either going to be 1 plus R for growth or 1 minus R for decay, where R is your rate of change and T is your time. We saw that on the front page. So in this example, here is our initial amount. So we start with 100. And that would be 100 milligrams of caffeine. This here is going to represent our base. So we need to find out how much less than 1 this is. So if we subtract 0.86 from 1, we would get 0.14. So our rate would be 14%. And since this number is less than 1, okay, since it's less than 1, we have a decay. If the number is greater than 1, then we have a growth. Half-life. So half-life's a little bit different. Half meaning it's being cut in half, so your rate would be equal to 50%. And if you take 1 minus 0.50, you get a base of a half. Hence the formula 1/2 as your base. Now something a little bit different here is in the word problem, it's going to tell you what your half-life is. It'll say straight up, the half-life is, for example, the half-life is 3 hours. Okay, what that means is that every 3 hours, the amount is going to be cut in half. And that would be your K value in this formula here. This is your half-life. Okay, so notice, if we start off with 200 grams sample, 3 hours, that's your half-life, we should have half of 200. 3 more hours, it should be cut in half again. 3 more hours, it's cut in half again. So using this formula for half-life, okay, writing the formula for this, it says the half-life is the amount of time it takes for half of the atoms in a sample to decay. A chemical substance will decay by half in 3 hours. The half-life is 3 hours. Complete the following table for 200 gram sample. So we're starting off with 200. So that's going to be our initial amount, our starting amount. It's decaying by a half. And then we just raise it to time over our half-life, which is, in this case, 3 hours. How much will be left after 10 hours? We would do 200 times a half. We're going to plug T in for time over the half-life. So T goes in for time. 3 is our half-life. We plug this into our calculator. So notice I have my initial amount, my half for half-life, my time, 10, and my half-life is 3. So we should have 19.8, approximately 19.8 grams. Okay, so let's see if that makes sense in our table. So after 10 hours, if we go to 10, which would be about right here, we should be a little bit less than 25. And sure enough, that's where we're at. Okay, moving on. Okay, let's talk about the compound interest. So P is our principal, which is our initial investment. So this is how much we start with. R is our interest rate. Always remember to use decimal, not percent. Okay. N, these two values here, the number of times compounded per year. So if it says monthly, it's compounded 12 times a year. Okay. Quarterly would be 4 times a year. Semi-annually, twice a year. And so let's see, what else? T, of course, is your time. See, A of T is the amount in the account after T years. So this would be your ending amount. After T years. So T is your independent variable, and the A of T, which represents Y, is your dependent variable. So let's go ahead and set up an equation here. Let's look at this example here for compound interest. So we got a starting amount of 4,000, which is going to be your P. That's how much we started with. Okay. Following this formula here, we have 1 plus the rate, which is 6%. Remember to use a decimal. Divide it by 100 if you don't know how to change it to a decimal. Over n. In this case, n is going to be 4 because it's compounded quarterly. Okay, raised to, again, n times raised to the 4t power, 4 times t. And so this would be the equation for this problem. Now, something to keep in mind here, this is being compounded months and years. So time is being compounded in months and years. So if I plug 0 in for t, then we get out 4,000. Okay, so what I did was I just paused the video for a minute so that I could plug this into my calculator. So notice after 0 years, we're starting off with 4,000. And in 1 year, we're at $4,245.45. Now, if I highlight that, you can see the black numbers here. That gives you the additional decimal places in case you need to round. So this is dollars and cents. So we're going to go 2 decimal places. Okay, 2 years. Go down 1. So for 2 years, we're at $4,505.97. Now, these are in months, so we have to convert these to part of a year. So we're going to put 3 over 12. It's 12 months in a year. So 3/12 of a year. So to get this amount, we'd have to do 1/4 of a year. 6/12, 1/2 of a year, and 9/12 is 3/4 of a year. So to get these dollar amounts, we would need to, well, what I would do is go to the calculator screen and then put the equation in. So time would be, for the first one, 1/4, which is 0.25. So in 3 months, I'd have $4,060. Okay, so half, go back up, enter, and then go back in and change that to 0.5. $4,120.90. And then 3/4 of a year, again, up, enter, change it to 3/4 or 0.75. Okay. So I already did the formula up on top. And then we would use that formula to answer these questions here or use the table. It says find the principal needed to have 5,000. So in this case, 5,000 is going to go ahead and go in the ending amount. And we would be looking for the principal in this case. And time's running out. So I'll see you tomorrow in class.